In this video, we're going to be explaining how to solve this problem here under quadratic equations with this algebra 1. Find the sum of all solutions to the equation 4x times x minus 3 equals 23. So, a quadratic equation is any of the equation of the form ax squared plus bx plus c equals 0. And you can tell right away that this equation here is not a quadratic. We've got a 23 on the other side. It's not 0. We can't really solve this equation right now because it's not in a form we know how to deal with. It's not a quadratic equation. This is all weird here. We've got terms being multiplied and we've got a 23. So before we do anything else, the first step we need to take is to get this into proper quadratic form. Just write down our proper quadratic form as a reference. Ax squared plus bx plus c equals 0, where c is a constant term, and we've got a and b. Those are both coefficients in this case. So, first thing we can do here is distribute this left side here. By distributive property, we have 4x squared minus 12x, and then our equals 23. Okay, that's bringing us one step closer. The next and final step is to subtract 23 here from both sides so that we have an equation that's equal to 0. So we wind up with 4x squared minus 12x minus 23 equals 0. Okay, so that is our completed quadratic form. We've got this thing into a familiar form we can manipulate now to find the sum of all solutions. Now you'll notice that the prompt's a bit different this time because it says the sum of all solutions. So in previous questions, it just said find the solution. So this says the sum of all solutions. So we've got sum here. We got to pay attention to, and this is a bit different. We have two approaches we could take here. We could go the long way and use our usual factorization trick and trial and error to manually go through and find two numbers that add to this and multiply to that. That's going to take a while. We've got some funky numbers here. We've got a coefficient of x here that's 4. Got this weird negative 23. We're going to have fractions involved here if we do it that way, and that's going to be not so good. So we want to find a different and easier way to do this that doesn't involve guessing and checking and doing all this crazy stuff that's going to waste time. So the way I solved this problem was there's a special way you can find the sum of all solutions to a quadratic equation. So if any equation of this form, ax squared plus bx plus c, the sum is going to be negative b over a. This down. Sum is negative b over a, where b is our constant coefficient here, and a is the coefficient of the x term. We just take the negative of whatever b is. So in this case, going back to our application of the quadratic here, our b is negative 12, and our a is 4. And this works for all quadratics of this form. You can use this formula to find the sum. Now, this isn't relevant in this problem, but the product of the roots is equal to c over a. That's also an important and useful fact to know. The product of the roots is c over a. Alright, so now we've got that down, we can now proceed to find the sum of all solutions here, now that we know this formula. So our b is negative 12. That means it's going to be 12 up top because the whole thing is negated. Over 4, that's our a. And that equals to 3. 12 over 4 is 3. And that's pretty much all there is to it. The problem simply asks us to find the sum of all solutions to this equation. And we discovered, and that's simply the formula for the sum of all solutions, is negative b over a. And that's what we applied right here. Now, notice the problem didn't ask us to find the solutions themselves. If it did, we would have had to go through the long, hard way anyway. If they asked for the product of the roots, we would have just had to do negative 23 over 4. Because the product of the roots is always going to be c over a. C is negative 23, and a is 4. So the product, even though they didn't ask for it, would be this, in case you were wondering. So the sum, in this case, is 3, and that answers our question here. That is the sum of all solutions to this equation. So in summary, what we did here is we first manipulated this strange-looking equation into a quadratic equation we knew how to solve, so that we could then apply the sum and product rules to solve this equation and find the sum of all solutions. Alright, that's pretty much it on this question from AOP's Algebra 1 homework, factoring quadratics and finding the sum of solutions.